Morning, we're back. Glad you came to join us again. We're going to talk about the application of the Mitsubishi equipment right now. So let me switch over to that and we'll get started. Not application, we're going to talk about product overview. I'm sorry. Can't remember where I left off, but hopefully you're following along. Okay, what we're going to be doing now is talking about the equipment a little bit. Now, on the equipment, we have these labels. This happens to be the label on an outdoor piece of equipment. It's a PXZ or MXZ 8C48 M series unit, starts with M. And that is the model number there, and underneath it's a service reference number. And then way down here at the bottom is the serial number. So it's important when you call us for help or call for a part that you give us the service reference number and the serial number. You might give us a model, service reference, and the serial number, but we definitely need the service reference number. On the indoor units, this is an indoor unit of an MVZ, and you'll notice down here is the serial number. We're kind of used to seeing the model and serial numbers together on most of our equipment that we sell and manufacture in the United States, but on the Mitsubishi units, you'll typically have the model number is going to be the first thing you see, and one of the last things you see on the labels will be the actual serial number. A lot of data on here. Again, this is a P series. It starts with a P and the service reference number and the serial number on the bottom. These are PKAs and MVZs are indoor units. This happens to be an outdoor unit, so this one's going to tell you your compressor information. It's going to tell you a little bit about refrigerant, and on this particular unit, it's a branch box. Anytime we have a branch box, we're going to add refrigerant, so they want you to write on here the total charge of the system when you're done. I always say carry a magic marker, and anytime you're doing something like adding refrigerant to a system, we never take it out, but we do add refrigerant to a system, and we're not adding because of a leak. We're adding because we have an extended line length or something like that. Or in the case of the MXZs, anytime the unit has a branch box, you definitely have to calculate the charge. So I would say inside the cover, so that you don't see it on the outside, but inside the cover, I would write the actual charge and maybe how many feet of pipe, how you figured it. Just some brief explanation so that if you go back in 5 or 6 or 10 years and you think the unit's low on charge or whatever, we can always remove the refrigerant, weigh it, and determine if it's got the original charge in it or not. I wanted to talk to you though, this service reference number, you'll notice on this model, it's one and the same. The model number and service reference number are the same. It is down here too. This one though, you'll notice the service reference number is the same as the model number, except it has a couple of other letters at the end, in this case MX. I'll give you another example over here. This particular model up here has a, let's see, can I get rid of that? Hang on. I can't see up here. I apologize. Let me see if I can make this go away or move it. Yeah. You can, this is an MUZ and MUY unit. Okay. Now, those units, it's MUZ GL09NA was the original model number. Then they added a U1 behind it in the service reference number. And now they just changed it to a U2 in the service reference number. Now, what that means is somewhere, the model number is still MUZ GL09NA, but the service reference number ends in U2. What does that mean? Why would that make any difference to you? Now, say you called in and you say, I need a compressor, or I need a reversing valve, or an expansion valve, or a linear expansion valve, or something on the unit. We're going to ask you what the model number is. What we really need is the service reference number. That is important, and this is why. On the service reference number, you notice up here, this is a U1, this is a U2 of the 09. The compressors are different. The four-way valve is different. The inverter board is different. As we go down here to this particular model, these grills, everything over here are different. So if you called in and say, I need a compressor for a MUZ GL09 NA, and don't give them the U1, you're going to get some compressor that doesn't fit your piece of equipment. So not a good thing when you ship it all the way up there and you get out to the job site, you tear the unit all apart and find out you got the wrong part. But make sure you give us a service reference number. It's very, very important. Let's talk a little bit about nomenclature. This is the M series nomenclature, that if it starts with an M or an S, I like it to say mini or small, mini split or small. That is our conventional residential type equipment. Starts with a P, we think of it as professional style. But if it starts with an M, it's a family. And if it has the next digit is a U, it would be a single system outdoor unit. Like an MUZ would be a heat pump, an outdoor heat pump. MUY would be an outdoor cooling only unit. In this case, it's an MX, so what it's telling us, the X indicates it's a multi-zone outdoor unit. In other words, we have one outdoor unit that can feed multiple indoor heads. And if it was a ME, it would be a horizontal ducted unit. MF would be a floor or low wall mounted unit. And ML is a ceiling. So we go, that second digit means an awful lot to us. This other digit here, again, Y would be cooling, Z would be a heat pump. And that, because this is a X, which is a multi-zone unit, this next digit here tells us how many zones we can support on this unit. We can go up to 8 zones. We have a minimum on all of our MXZ models. You have to have at least 2 indoor heads. But we can do up to 8 on this unit. So anywhere between 2 and 8 on this particular unit. C is just a system generation change. The old was an MXZ 8B. This is now an 8C. 48 is 48,000 BTUs or 4 tons of cooling. The next digit N was just a voltage designator. We've pretty much been mostly 230 volts for the last probably 8 years. We used to have a, back here they're talking about an M, like an MS09 was a 115 volt non-inverter model, and that would have a W in it. When we get to equipment a little bit later on, I'll point out that we do now have a 115 volt unit available again. That's just a wiring control method, and then this is the model revision number. And maybe if they make a change in the equipment, that last digit will change. And that's kind of like the service reference number we were just talking about. If it ends in HZ, that means that it is a hyperheat model. HZ indicates hyperheat. So it would have this particular symbol. That would be a hyperheat, would be, Z tells it's a heat pump. The hyperheat would tell us that it's available to heat at very, very low ambient temperatures, where they get a lot more heat out of it. And this is the type of equipment we have. We have a wall head that looks like this. This has 2 different louvers that are able to fluctuate up and down, and then the louvers inside can blow the air all different ways, either in tandem, or it has a ability of doing a natural breeze, which just kind of throws air all over the place and gives everybody just a little waft of air once in a while. Also, right underneath here, we have a IC sensor on this particular model. This model allows you to do an occupied, unoccupied with the IC sensor. In other words, if there's nobody in the room, we shift the set point, make it a little bit more economical to heat and cool with, just a couple degrees. And then if somebody walks in the room, it goes back to set point. It also has the ability of distinguishing a human being in the room. So if somebody walks into the room and you want the air to blow towards them, they sit down in their easy chair or their desk, it will blow the air directly on them based on the IC sensor sensing them in the room. Also has the ability of blowing the air away from somebody. So if this is in an office space, for instance, and the secretary is complaining, I don't like that air blowing on me, you can set this thing up to make sure that if she's sitting at her desk, it doesn't blow the air directly on her. If she moves over to another desk or to the copy machine, this little IC sensor that goes really slow and monitors the room eventually would come to where she is in the other part of the room and say, oh, there's a person here, blow it away from them. So kind of neat. This is a floor unit or low wall mounted unit. It doesn't necessarily mount on the floor. It mounts just above the mop board or the molding on the floor. The line sets come out this bottom left or this bottom right hand corner here, and right at the bottom of the unit. So if this thing was tight to the floor and you tried to drill your line sets through there and your electrical and your condensate drain through the little 3-inch hole, it would you'd hit the sill plate in the inside the wall. So you want to make sure you're up and above that. So I say as long as you're up a few inches, an inch or so above the mop board, you should be plenty good. And then you're also not having to cut into any of their woodwork. That's kind of a bonus there. These are your typical wall units. There's different ones that mount on different units. This is just our standard unit that gets up into the high SEER ratings. This HM and WR and these units over here are units that I would consider them being a little lower cost, better value, more affordable type units to compete against the competition. The difference is these start at 16 SEER and 18 SEER, right in that range. And where these over here and here could be up to 33. So it is a little less SEER, but that's where our competition is. And if that's what you have to do to sell the job is drop the efficiency down and give them a little lesser value unit, you have that ability to do that. Little kind of example of the outdoor units. There's a single fan like these, and there's a bigger unit that has another fan on it. So we'll show you some pictures of them as we're coming up. Then we have this air handler here, this SVZ air handler. These little knockouts here are for condensate. This is a horizontal left, horizontal right, upflow, and it can be a downflow unit as well. If it's downflow, you remove this coil, flip the unit over, just flip it over and push the coil back in because you want the drain line obviously on the bottom so that the condensate will run out of this unit very nicely. We also have an electric heat option that fits right on the top of this unit if you want. And I've even had people put hot water coils in there and we can turn them on and off with this equipment as well. This unit, this air handler, is capable of 9/10 of an inch of static. So it's very similar to a conventional furnace or air handler that you're used to. So you could put this in a basement and do essentially a whole house or a very large zone with this type of unit. Put it up in an attic, crawl space, it would work just fine. This is a ceiling cassette. It's 2 foot by 2 foot. It has a electrical box and a condensate lift mechanism in the unit, which is not a pump. The condensate lift mechanism lifts the water off the bottom of this unit here, off the drain pan, and slings it out of the equipment up here at the top, and then it would gravity feed from there into just a gravity feed drain, or you could gravity feed into a pump and pump it someplace. This unit does have an electrical box back here, so you have to have access to it. This is intended to be mounted in a drop ceiling where you can just lift out a ceiling tile, go up there and work on it, and that'd be fine. If you're going to mount this somehow in like a sheetrock type building, and you have the room, because you need at least 2 feet of space to get this in, and 2 feet on center joists, there's not enough room because the the 2x4 sits this way and it's 2 feet to the center. So you can't physically shove it up there, and you can't cut a joist. So you don't want to use this unless it is designed and structurally sound to put up in there. And then once you get it up in there, you have to be able to get to the box to do service on it eventually. So if you're in an attic, you could climb up in the attic and maybe service it. If you're in a lower floor, you'd have to have some sort of a trap door next to it to get up and work on it. Notice this little round thing here. That's giving you the ability of putting in fresh air into this unit. And this little thing here, you have the ability, it doesn't come with it, but you have this same IC type sensor that you can mount on this unit as well. Then we have these little air handlers. These things are only maybe 8-10 inches thick. This particular one runs like, I don't know, 3/10 of an inch of static. It's very low static on this one, so you can't put much duct work on it. Maybe 6, 8, 10 feet of duct work and just a couple of runs off, designed to put either a grill right here and blow directly into the room with a return air grill out the back, or a small piece of duct work and just run some ducting into a couple of bedrooms. So very, you got to be careful where you put this, because you can't do a whole lot of duct work on this thing. This thing you do maybe 2-3 bedrooms, just takeoffs and short little run of duct work. And the takeoffs I would normally run, if you're going to use flex guy, run at least 8 inches, just because you got to reduce that static as much as you can to run this unit. This PEAD will run up to 6/10 of an inch of static, so you can put a little bit more duct work on this. We sell a lot more PEADs, but just be aware that there is 2 different models available. This little unit I'll talk about next, it is a ceiling cassette. It's very similar to this one, but this one is designed to mount up into the ceiling. It goes between 16 on center floor joists or rafters. So if there are 16 inches on center and at least a 2x9 or 2x8, I'm sorry, 2x8, it will mount in there because it's less than 7.5 inches. So it will mount into a 2x8 or a 2x10 is the typical floor joist, or larger. This, unlike the other ceiling cassette, this one is designed to have 100% accessibility to the bottom for service. You can get to your electrical panels, you can get to everything you pretty much need to from below. Your refrigerant lines come in one end and your electrical lines come in the other. So this also has a condensate lift mechanism in it. Comes with a remote control. By the way, anything that starts with the letter M, and it's an indoor unit, if it starts with letter M, it comes with a remote control. Let me just back up one here. These units are SVZs, PEAs, SEZs, SLZs. These units do not come with a remote control. All these others do start with an M, and they all come with a remote control. So just be aware of that. This is a new model. There's SUZ. There's a hyperheat version of this, and this is the standard heat pump version of this. Comes from between 9 and 36,000 BTUs. It's kind of a universal outdoor unit because all of these units here were originally designed for the MXZ multi-zone unit, and we got a lot of requests. Can we use like that air handler on a 1-to-1 or a ceiling cassette on a 1-to-1? And then in the old days, we'd say no. Now we do have a unit that is kind of universal. It has a lot of different indoor equipment that will hook to it. Not every piece of indoor equipment will hook to this, so you have to verify it, but all of this style does. Also, something new this last year was a 115-volt wall-mounted inverter-driven heat pump. It is not a hyperheat. It's a standard heat pump. It is 115 volts. It's only available 9,000 and 12,000 BTUs. And I think it's a 15 amp circuit. You can run this thing on. It's very low voltage usage, so you should be able to use this in most instances if you can't get 220 volt to it. this gives you an option. That CN105 connector that we're talking about on there is, it's a little red connector. CN in Mitsubishi languages, CN stands for connector. So this is connector number 105. It gives you the ability to hook up additional controls. This starts with an M, so it comes with a remote control, but if you want to hook up other controls to it, we have that ability to do that. We'll talk about other controls later on. Also at this point, I should mention that all heat pumps require the unit to be up on a stand, so sitting up off the ground and totally open on the bottom so water can flow off of this thing. Not just elevated like on a platform. You can't do that because the water, when it comes through a defrost mode, water pours out of this unit. And it has to totally leave the unit and drop onto the ground. Because once it hits the ground, it's going to start freezing. That water turns to ice and it builds up. And if you sit our unit on the ground or on a pad, that water will freeze up, eventually hit the bottom of the coil, push up the bottom of the coil and actually damage it. It'll actually crush the coil, and then you get a leak and a restriction and possibly water in the system, and you got a real mess, and you don't want to go there. So in our market, we're in a market that is cooling, or a very cold market that requires heat. All of our heat pumps are required to be up on a stand, and they should have what we call a base pan heater installed. Base pan heater is an option on a standard heat pump. The hyperheat units all come with a base pan heater. Base pan heater, your cost is like, I think it's $200 for a base pan heater, somewhere in there, and plus the labor to put it in and so forth. To me, in most cases, it just doesn't pay to put a non-hyperheat in our market, because it's going to save you the time and energy and the cost of putting in a base pan heater. But they all have to be elevated. Now, I always get the question of why, if it has to be required in a standard heat pump, why don't we just ship all heat pumps with it? Well, in south of the Mason-Dixon line, where it doesn't get below zero, there's no need for that. Even if it does drop below freezing, below 32, it's going to warm up and it's going to melt, and temperatures fluctuate. If you're in like South Carolina or someplace like that, it's just not required. If you're in Texas, it gets cold, you need heat pump, but you're never going to freeze on the ground. So that base pan heater is not required in that market. So a quarter of the country requires a base pan heater, and unfortunately we're in that part that it is required, and it is required that you put it up on a stand or a bracket, a wall bracket of some sort, someplace where you're up off the ground and that water can flow off of the unit. So, okay, the MXZ multi-zone units, there's a 2C20, that's 2 zones, 20,000 BTUs, 3 zones, 24,000, and so on and so forth. You'll notice on this model, this is the standard heat pump model, so this does require, this is a hyperheat unit, so this does not require a factory installed base pan. There's 3 models here that are what we call ported types. There's ports on the outdoor unit, so there'd be 2 ports for 2 zones, 3 ports or 3 sets of ports for 3 zones on these units. And when you get to a 3-ton, 3.5, and 4-ton, that requires a branch box. So the branch box typically gets mounted on the inside of the dwelling, and it can be put up in an attic, or it can put in the basement or in a closet or someplace like that, but it does normally get mounted inside. There is now a package that you can buy to mount the branch box outside if you want to. So that is available. But just be aware that anytime you use a branch box, you are going to add refrigerant as well. This chart is in the catalog. It also shows all the different models that get mounted to that. Again, any of these that start with an M come with a little infrared remote control. And any of these here that don't start with an M require some additional type of control to be added as an accessory and charged for. Okay, this is the non-hyperheat model. This is the standard heat pump. This one does require a base fan heater, but you'll notice that the 20 all the way up through the 42,000 do not require a base fan. So there's a couple models in here that you might want to sell either way. Maybe you don't want to sell hyperheat just because you have no place to mount that branch box. So it gives you a little bit more options here. And then there is a 5-ton unit available in the non-hyperheat with a branch box. And again, it mounts on all this equipment here. This is what the equipment looks like. This is the non-hyperheat model. There's the 2-fan condensing unit. There is a 3 branch or 3 ports branch box available on there. And on the hyperheat model, we have got again, a 3-port branch box, but it's available in a 5 and a 3. If you're going to sell 8 zones, you have to put 2 different branch boxes in. And it would be similar to this. This would be a 5-zone branch box. You've got 5 indoor zones off of 1 branch box. If you wanted to have 2 branch boxes, you have to put a T in here. There's a pipe joint available, and you just tee off to, say, a 3-zone and a 3-zone. You could put 6 zones in, put 2 3-zone branches. You could put a 3 and a 5 zone. You can do some different things. If you put 2 5 zones in, it doesn't give you 10 zones. You still only have 8 zones. That's all this unit will do, is up to 8 zones. Also, I would like to add at this point that all zones should be sized properly and that they will be similar temperatures. In other words, all zones should be set for, say, 72 degrees heat. You can't have one doing cooling and one doing heating. That does not work. Auto changer does not work on this equipment. And you can't expect one room to be set at 65 and one at 72 and have it work properly. They're made to be similar zones. I will tell you that this outdoor unit, let's go back a couple. This outdoor unit coil is huge. It really basically covers this whole unit here on the backside and then wraps around this corner. Huge coil. So if you get into the indoor heads and you have just a few indoor heads calling, the size of the coil is relatively small in here, and in the heat pump mode, that makes these inside coils the condensers and the outside coil the evaporator. We have to have some place to put the liquid refrigerant. So the expansion valves, the linear expansion valves, do not close down 100% to allow us to store some liquid in the zones that aren't calling. And if you oversize these zones drastically, or you're trying to have one little zone down in the basement call for heat and keep the basement at 78 degrees and the rest of the house at 65, it's not going to work. You're going to still get some heat off of these units, although not much, especially if they're sized properly. You're not going to get much heat off of them, but you can get some and overshoot some zones. So it's important that we size this right. If you've got any questions, you can call us at any time and we'll walk you through it. We can do a thermal off on the fan and use an external temperature sensor in the space. Because remember, we're looking at return air temperature. We're looking at return air temperature. We're going to leave that fan run a little very slow speed constantly. And if we're leaking liquid refrigerant in here, this could be putting out a little bit of trickle of heat. If it's sized properly, it's very little, then nobody will ever notice any heat. If you oversize one and you have a smaller zone that's maybe undersized calling all the time or set very, very hot, you could overshoot these zones. So just be aware of that. And if you got any questions, call us and we can, any of us can walk you through that at any time. On the branch boxes and on the ported units, there's typically several ports that'll be like 1/4 and 3/8, and there may be one port that's 3/8 and half. When you're sizing the indoor unit, if the indoor unit head has 1/4 3/8, you run a 1/4 3/8 line from the indoor unit to the outdoor unit. When you get to the outdoor unit, if you find that you have one port this 3/8 by half and you've got 1/4 3/8, you make that transition at the outdoor unit. You don't make that transition at the indoor unit. You make it at the outdoor unit. Makes more sense. You're running less expensive copper that way as well. But you want to make that transition at the outdoor unit. There's these port adapters. They're listed in the submittal data. They're listed in a number of places as accessories on MyLink Drive and so forth. We also have a chart like this that I put together a few years ago that convert from the Mitsubishi part number to a standard fitting so that we can have either one available to you. The one's a little bit shorter, a little bit less work. This has a braze, for instance, here and here, and you can see there's basically 3 fittings and a piece of copper tubing to make this, or we have one fitting that will do the whole thing. This fitting's a little less expensive, more affordable, better value type of thing. But we stock all this. We should have all these in inventory, or can get them very, very fast for you if you need a fitting like that. Okay, the P series, the PKA, is a light commercial line, and the P stands for professional. The K would be the type of indoor head. That would be a wall-mounted indoor head, and if it was a PU, it would be an outdoor unit. So very, very similar nomenclature that we use on the M series as well. The A would indicate cooling only, or the A would indicate both heating and cooling. If it was a Y, it was cooling only, or Z is a heat pump. Now you're saying, I don't understand it. Both heating and cooling, or Z is a heat pump. If this is a U, if this is a PUY, that U would indicate that it's a single system outdoor unit. There is no multi-system P series. So it would be a PUY would be cooling only, PUZ would be a heat pump. But because this is a K, that's telling us it's a wall-mounted indoor unit. If there's a PKA, that's saying the wall-mounted indoor unit is capable of cooling and heating. On the M series, when you buy a wall-mounted unit, you buy either a heat pump type unit or you buy a cooling type indoor unit. So a little different when we get to the P series. The A would just be a generational change, or if it said HA in there, that would be a hyperheat, because we have hyperheats available on the P series. The 24, very similar to the M series, that's 24,000 BTUs or 2 tons. And then we have some system controls generation and a model number version or revision. We're now at 7 on the end. Now, why P? What makes it special? We have a lot longer line lengths. We have pre-charged lines that run longer. We can add refrigerant, run up to 165 feet on some units, all the way up to 225 feet on some, where our competition can only go up to about 98 feet, 82 or 98 feet, depending upon the competition. We can go 165 or 225 with this model. So go a lot further lines. We have continuous operation. These things will run continuously without shutting off, where the M series do have to ramp up and shut off and do some things to get oil back. And they also don't start up quickly. The Y series or the M series can take up to 10 minutes to get up to full speed. Where these units, say there's a power failure, when they come on, they ramp up to full speed. Won't say instantly, but probably within seconds. Definitely, I've seen them ramp up less than a minute to get up to full speed. So if you're using this in like a server room or some type of equipment room, you need that power, you need that thing to come up and run very fast. And this will do that. It's got high pressure protection in it. There's just a lot of different things in it to make it work a lot better under commercial conditions. Also, it has a BS on the end for a blue spray. You will see some of our equipment coming with coils that are there's a slight bluish tinge to them. That means that they've got this blue spray on it for, used to be, we sold them along the ocean because they are less likely to corrode. We've been selling a lot of them because there's a number of companies we have that do work on tugboats and boats, that they mount this equipment on a deck of a boat. And I'm not talking about a little runabout. I'm talking about a fairly good sized boat. There's some up on Lake Superior and all. We do a lot of that. We always put the spray on that because they're less susceptible to the environment. You will see it on some of our equipment. Some of it is now, some of the MXZ units are starting to ship with that as a standard item. We used to have to pay extra for it. Now it's coming on a lot of the equipment. So just don't be concerned if the coil's a little bluish tinge to it. It's not an obnoxious blue like this. It's just got a very slight blue tinge to it. Okay, the P series, the PKA. In our catalog, and this is true for M series, anytime you see a blue band like this on the model numbers, this is the matchups between the indoor and the outdoor units. If it's blue, it's an AC cooling only unit. If it's red, it would be a heat pump. That's true in the M and the P series. So the PKA wall units look like this. Is a PCA. By the way, this is available. You can use this on some of the multi-zone units. You have to look at the chart, find out which ones are available. But that again is a P series, available in cooling and heat pump. This wall cassette is available in cooling and heat pump. This wall cassette is about 33 inches by 33 inches. It's a lot bigger than the M series we looked at. This does have a knockout here for fresh air, and it has a knockout on the side, so we can actually run a little piece of duct off of this to throw a little air into an adjacent room, like I say, a restroom or a walk-in closet or something. You can throw some air off and drop it into another room. Also, on the residential and the commercial side, these louvers we can turn one or two of them off if we need to. If they're blowing on somebody's face or something that we don't want blowing on, we can shut them off. Here's that PEAD air handler. That's the one with 0.6 of an inch of static. There is a air handler similar to what I showed you, the SVZ air handler on the M series. This one, though, however, is a little bit taller. It's probably about 10 inches taller than the other one, and comes in some other sizes. This goes all the way up to 42,000 BTUs, I believe. And you'll notice none of these start with the letter M. So that because they don't start with an M, you have to sell some sort of a control. We have a number of controls we'll talk about a little bit later, but that's a PAR. Used to be called a PAR 33. It's being upgraded and replaced by a PAR 40. Very, very similar, no real differences that I have found. This is what they call a simple MA, is a PAC YT53 is the model number. And this is a simple touch MA, very similar to this, but it's got a touch screen on it, and it's got some colors, and you can upload a logo or whatever into that. So it's kind of a neat little stat. But that is these are options for hardware stats. They have 2 wires, 18 gauge 2-wire thermostat wire to hook them up. Then we have that, I mentioned that CN105 connector. These little wiring harnesses here that we show on here, these all would plug in that CN105 connector. This is a Kumo Cloud, which is a Wi-Fi device. So if you plug it in, you can have access to any of our equipment, residential or commercial. You'd have to have one for each inside head for each inside, whether it be air handler or whatever. And then you can control it from anywhere in the world over your smart device, as long as you have web access. There is a BACnet Modbus interface. There's a thermostat. This is a conventional thermostat interface, which allows you to hook up some other, say you want to put a Honeywell or a Nest thermostat, and I'm not a fond lover of Nest thermostat, so I'm not recommending them in any way, shape, or form on this, although we do sell them. But it would have to be a two-stage thermostat. So if it's a cooling only, it'd be two-stage cooling. If it's a heat pump, it'd be two heat, two cool. And then that would control off of a standard thermostat. You also need to install a 24-volt transformer. So it'd be a 240 volt to 24 volt transformer. Mitsubishi sells a small one that's 5 VA. If you guys are familiar with our Nexia, like 824 type thermostats, that requires 7 VA. So to do that, you'd have to put a bigger transformer on, find a place to mount it. You've got this US NAP interface available. You've got just some options. This is the Kumo wireless touch, called an MHK2. For years we sold an MHK1, and it's slowly being replaced. This we don't have any in stock yet, but we will be getting them very shortly. As soon as Mitsubishi runs out of the MHK1, they're going to start shipping this MHK2. So that is very similar to the MHK1. It's made by Honeywell for Mitsubishi. It is a RedLink device. So this device plugs into that CN105 connector, and this device can be mounted inside or alongside the indoor head, and it talks RedLink to this thermostat, which is a wireless thermostat that you can basically mount anywhere in the space. The default for this thermostat is that the sensor, you're sensing the room temperature at this device rather than the return air. Although you can go into the menu and you can tell it to sense at the return air if you would rather. And you can do thermal off for your fan and things like that, all through the menu that you can get to from this device. And then these, I said, none of these have an infrared remote, but there is an infrared remote that you can buy for that. This is a receiver that you would have to mount for any of these units here, would be receiver. These units these units here have a receiver built in, so all you would need to do is buy the remote if you wanted to control these with a remote control. But again, we kind of think of these as commercial, and a remote control in a commercial space is not necessarily the best. Okay, there we go. Oh, the PUY, which is the cooling only, that ends in a -7 now. If you just put that outside, you will get, it will give you 100% cooling capacity down to 23 degrees. If you mount a front wind baffle on it, it's good down to 0 degrees. If you put the front, rear, and side wind baffle on it, it is give you 100% cooling capacity at -40. So this is the type of equipment that we would probably put in computer rooms, elevator equipment rooms. We use a lot for that. Any kind of remote communication buildings like cell tower buildings and telephone company buildings that require, those would require cooling all winter long. Any type of medical equipment, imaging buildings or trailers, that sort of commercial kitchens, any of that type of place. If it be critical cooling, like a computer room, server room, might be considered critical, or the medical building might be considered critical that they can't afford to be down. So if there's a problem with the equipment, they want 100% redundancy or backup system, then we have the ability with that, a par 33, par 40 thermostat of doing lead lag so that we have redundancy. We say there's a 1 ton load in the building, we would put 2 1-ton pieces of equipment in there, and we'd have one control that would control both, and if one failed, it would revert to the other one, or we would do lead lag. That would be considered critical cooling, where they can absolutely not afford to be down even for minutes. Then we can do that too with this type of equipment. So that's it for that. Now we're going to go into application, but I will stop the video at this time and we'll take a little break, and I'll be back when you're ready. Thanks.